Okay, so thank you everyone for joining our session today. I'm Sonia Barboza and I manage curation for Harvard's Dataverse, and I will be chairing this session with Julian, who many of you have also met during the community meeting here. Julian is actually going to start with a bit of an introduction to our panelists and what we will be discussing today. So thank you everyone for coming. And again, I have access to most of your presentations. If your computer or anything is not working, let me know. I'm happy to pull up your presentation for you. That's for the panelists. So Julian, you can take it away whenever you are ready.
Hi, thanks, Tanya. I'm going to share my screen again. I just wanted to post this here, Zoom etiquette during breakouts. Please keep muted unless you're ready to talk, but I think we are going to not, we're going to let the presenters speak and then take questions afterwards, just like the last session on terms of use and licensing. And this meeting is being recorded and the recording will be made public. Where is it going? There you go. I wanted to provide a little bit of continuity from the last Dataverse community meeting, which also had a sensitive data session where we spoke about data tags, OpenDP, and the Impact Project and TSRA. Data tags, there's a Dataverse NL-led grant proposal that includes adapting data tags. And then we've also heard from Slava about recent plans with implementation of data tags that they worked on. For OpenDP, there's continued work on the library and DP Creator, and we'll be hearing from Ellen and Raman about that today. And there's ongoing, for TSRA, there's ongoing development work, but nothing to report for this community meeting. So the updates for the Dataverse software related to sensitive data included, the introduction of auxiliary files released in, different variants of it released in Dataverse 5.3 and 5.5. How metadata is released or not released for restricted files, specifically variable level metadata, and that was released in version 5.4, and including sign URLs in the external tools framework. And these are all like infrastructural developments that are put in place in preparation for more planned work to support sensitive data. So first we'll be hearing from Raman Prasad and Ellen Krasmiller about Dataverse and OpenDP, and then from Sebastian Kocher about how QDR handles sensitive data. And then from Julie Goldman about preparing for sensitive data use throughout the data lifecycle, and from Caroline Wood about health policy research data, specifically at Harvard, the Harvard Medical School. And I think that's it. So I will pass it on to Raman and Ellen.
Great, thanks so much, Julian. Hi, everyone, and it's a shame that we're doing this on Zoom and not in person. Today, Ellen and I, who are both members of the OpenDP development team, Ellen, as you know, is also a core member of the Dataverse team. We want to talk about the challenge of sharing sensitive data. And we have a lot in this brief time, but we really want to stick with 3 points. One is that releasing statistics reveals information about individuals. 2, that differential privacy is a method of creating safe to share statistics. And 3, we're going to show you DP Creator, which is an application in process that will bring differential privacy to Dataverse. So I want to start off with an example that comes to us courtesy of Ethan, who's also on the OpenDP team. And it's just showing how sharing data can lead to basically privacy loss. So in this example, pretend we're in a class that has 5 students, and the teacher writes the average exam score on the chalkboard, which is an 85. And then the next thing that happens is that one of your classmates drops out and joins the circus, which has happened to all of us at different times. And the teacher goes back to the board and writes that the average exam grade is an 84. Now the question is, has your friend's privacy been violated? And by doing some relatively simple math, we can find that, this first equation shows, that the average score is an 85 with 5 people, and here it's an 84 with 4 people. And if we kind of, break these out a little further with some subtraction, we could find out that once your friend, who is, X over here left, that their score is an 89. And if anyone isn't following me or it's too fast, please feel free to raise your hand. So, in this simple example, your friend's privacy has been violated. And it's an example of how releasing statistics can tell us information about individuals. In this case, we may not care. Maybe your friend who joined the circus wasn't that close, but the implications for this are huge. In that, in the 2010 census, there were over 308 million individuals, and in 2016, the census took their published statistics, their publicly available statistics, and they did what was called a reconstruction attack. And from these statistics, they were able to make kind of rows in a data set that accurately showed 71% of the population in terms of sex, race, age, and ethnicity. Now, there are no names or addresses attached to this data set. They really were just trying to see, what are we losing when we release public statistics. The next thing they did was they linked this data set to a commercial database which did have names and addresses, and they did some more validation, and they found out that in this commercial database did not have factors such as race and ethnicity, or features such as race and ethnicity. And what they were able to do is link the names and addresses of 52 million people to their race and ethnicity. And there's basically a law that says the census cannot reveal confidential information, and they did. And if anyone's interested, this link, which will be passed around later, has a lot more details on that exercise. And now, so we looked at the classroom and we looked at the census. Now, this also has implications for Dataverse. So, as you know, on the Harvard Dataverse, there are thousands of restricted files. And data set owners, in many cases, might want to share statistics about these files. And on the same level, researchers who may think a data set is interesting, they may want to see some statistics about a private data set before going through the sometimes onerous process of getting permission to look at the underlying data. And so the question is, in all these cases, how could this be avoided? And the one way to kind of avoid the problem of leaking private data is differential privacy. And in a very, very simplistic way, we add a randomized noise to data. So if we go back to that average of 85, the original one, if the teacher could add a random number, it could be negative, it could be positive, and doesn't reveal what that number is, she might be able to post an average grade that is accurate enough to use, but isn't revealing any underlying data. And the same thing, when someone leaves, that same exercise can be followed again, of basically adding noise to the data. And when this is done, you can't reverse engineer your friend's grade. You can maybe figure out a range of what your friend's grade is, but you can't identify his individual grade. And and this is great because there's sort of this accuracy privacy balance. The statistic is still useful, but you can't find out anything about the individual person. And this noise that we're adding, and I'm just going to mention this briefly, I'll come up later, is known as epsilon. It's a privacy loss parameter. And so overall, differential privacy, if you have your sensitive data set and you add this privacy loss parameter, you can run through some differentially private implementation and come out with statistics that preserve privacy. So what OpenDP is an effort to kind of build open source tools that do this. There's a lot of proprietary tools out there, made by Uber and Microsoft, et cetera. And now we're really trying to make an open source library so people can use it for themselves, as well as make sure that it's kind of holding up the promise of differential privacy. And in this effort, there's several people on this call who are involved too. This library could be used as simply as like a pip install within a notebook, but it can also be used. It's not monolithic. It's this like kind of modular library. It can also be used in applications. So one application we're creating, which we're calling DP Creator, is going to let people like create statistics from their Dataverse data sets that are differentially private. And after they're created, they can be put back into Dataverse as auxiliary files and actually shared with the world without leaking underlying information. And now I'm going to turn it over to Ellen, who's going to talk more about the DP Creator.
Great, thank you, Raman. Okay, so now can you see my slides?
Yes.
Yes.
Okay. DP Creator, as Raman said, is a tool that uses the algorithms in the OpenDP library to create differentially private statistics for any type of data set. But for this first implementation, we're specifically integrating into Dataverse using the external tool API. So DP Creator can be integrated as an external tool, and it will download your Dataverse file and metadata in order to run the algorithms, and then it will upload the differentially private statistics as an auxiliary file. We're going to be using the signed URLs, which Julian mentioned, for added security, so that the API token is never sent over and shared to the DP Creator tool. So now I'm going to go to the tool. Well, first I'm going to. Okay, so this is an example of a call to DP Creator from Dataverse. So you have your Dataverse file that you want to create a statistic for, and you make a request to the DP Creator tool. And you click through. DP Creator requires an account as well. So you create an account here. I'm just using a Google account. And then once you do that, then you're brought to this main screen where you can begin the process of creating your DP statistic. You can see this is what was sent over from the Dataverse to create the statistic. So these next few pages are basically a wizard that you step through to answer questions about your data set and provide information about your variables so that we can generate the statistics. So it should be private information, private and sensitive information, and it needs to be one individual per row. If I'd answered the wrong question for any of this, it would have kicked me out. And then the next thing that happens is DP Creator contacts the Dataverse through the API to get the metadata, and then you as the user provide additional information about the ranges for these various variables that you're going to create statistics for. And then again, you answer more questions about your data, which will be used by the OpenDP algorithms to generate the epsilon for your data set. And so here we have epsilon that's been generated and related variables. And the epsilon can be thought of as your privacy budget. Whenever you create a differentially private statistic, you're using your privacy budget. So this epsilon is a way of like guaranteeing as you're working with your data that you're not leaking privacy. Okay. I went back to the wrong page. Okay, so we'll go here. Okay. So now what you do is create your statistic. And to do that, you choose which statistic you want to create here. For example, you can create a mean of income, which is one of the variables in your data set. And then continue, and then you're given a final step to make sure that you're ready to submit the statistics to generate the DP data. And this will take a while, so you'll be notified by email when it's done. And when it is done, it will be sent back to the Dataverse as an auxiliary file in all these different formats, and also be available here. So that's basically a run through. And just to reiterate the main idea of OpenDP is that, as Raman said, releasing statistics reveals information about individuals, and we want to avoid that. And differential privacy gives us the ability to do that. And with DP Creator integrating into Dataverse, we can create DP statistics for your Dataverse data sets. Stop sharing.
Great. And just a last note to add is that there's a big team working on OpenDP, and Tanya's been leading a lot of user testing around it, and we hope to be showing it off later this year. Thanks.
Thanks, Raman and Ellen. Sebastian is up next with current processes and next steps from QDR.
Are you seeing my slides?
Yes.
Yes, we are.
Excellent. All right. Thanks for having me. This is going to be completely different than the last presentation. That's the fun about sensitive data. It's kind of goes in very different direction and involves lots of different considerations. So I'm going to talk about what we do at QDR and what we want to do at QDR, and then also talk a little bit about different form of sensitivity, namely peer review. So this is a very rough abstraction how we think of sensitive data, right? Data can be more or less identifiable, and it can be more or less high risk. And depending on where you fall on this, right, the data is more or less sensitive. So if you're pretty certain that the data is identifiable and it's high risk data, right, risk to health, or livelihood, etc., of participants, that's really highly sensitive data. If you're pretty sure the data are well de-identified, and even if they come out, maybe you have some reputational loss, maybe a little uncomfortable, but people are not going to lose their jobs or anything, let alone be at physical risks. It's low sensitivity data, right? It's not no sensitivity data, but you feel somewhat differently about the nature of the data. And that's kind of how we think about that, and how we handle the data, of course, depends on how we classify it. Most data, including sensitive data that we have, is de-identified, but there is in qualitative data essentially always remaining disclosure risks. And so if you think of a scenario, right, we have data that are qualitative interviews there where you remove anything, do very good job. All direct identifiers are removed. You remove everything that's even remotely identifying in terms of indirect identifiers. But then, you know, someone from the same village or reads that transcripts, and there's this this guy who always uses that turn of phrase, or always tells that story, right? Those sorts of things. There's just no way you can remove every last bit of disclosure risk from qualitative data. Where we see shared sensitive data on QDR, we almost always get low risk data. We find that both IRBs and researchers are quite skeptical about sharing high risk and highly sensitive qualitative data. We're trying to convince both groups really that with the right access restrictions and the right protocols, things can be shared, but there's of course multiple levels involved, right? There's the trust of the researchers into the repository. There's the trust relationship between the researchers and the researchers and the participants involved, and those, you know, interact with each other, all those things. So it's a difficult and slow process. And so most of the sensitive qualitative data that we have is not the type of thing, you know, this comes out, people are going to get killed, but you know, this probably shouldn't come out because he told people it wasn't going to, and so let's protect it a little bit more. Accordingly, by far our most common access condition is that we verify the identity of the people requesting the data, that they have a legitimate interest in the data. So they submit a brief research plan and their affiliation, and then they confirm that they destroy the data. This isn't strong protection of data. They still get to work with the data as a whole, but it kind of gives us a layer of security, for example, against the scenario that I described earlier, where someone, you know, from the same village goes snooping and then identifies the juicy details from that qualitative interview, say. How this looks is we start essentially any process that involves human participant data, whether it's sensitive or not, that we review the consent protocol and often the IRB protocol to see what were participants actually told, what was agreed to with the IRB. We find, and those of you who curate data will probably be able to confirm that researchers aren't always very attuned to what exactly they told participants or their IRB was going to happen with the data related to data sharing. And then together with the participants, we have with the researchers, we have a conversation about disclosure risks, about potential risks to participants, right? What are the risk scenarios here? What are we worried about? And then we come up with access conditions that we feel tend to be on the conservative side, right? Because it is qualitative data. This is all fairly new, and so we really don't want to take risks. But often it really comes down to research. The data seem fairly safe to us, and researchers tell us, I have these remaining concerns, so I don't want these data to be easily downloadable. Can we put some additional protections on this? And so for most of the data, and that's this kind of low sensitivity data, we use the plain Dataverse restricted data feature. The data are on our Dataverse servers. They're not encrypted at risk. They are protected by the restricted function. People can request access to data, and then we contact them by email. We ask them for the information required in the conditions of access, and then as we get that, we give them access. We typically then put into our customer relations management software, we put a reminder so that we get back in touch with them after a year to make sure they're still using the data or have destroyed it as per our dedicated special download agreement for restricted data. As we have higher sensitivity data, our current protocols is to store those outside of Dataverse on protected Syracuse University servers with additional encryption, and then where we get requests for them, we zip them with AES 256 and find some way to convey the password to that separate. So fairly kind of non-automated, but also very rare kind of procedure. There's the additional preservation layer to this. Our preservation environment is built into our deposit and into our publication process. The moment a data set gets published, we push a preservation copy with the Baggett that Jim built a while ago to Google Cloud. Our servers are on Amazon, so we push to a different cloud provider in a different region in an archival format. But because the highly sensitive files aren't in our Dataverse, that's not included into our standard preservation workflow. So some of the things that we are really interested in looking at, encryption at rest, I think will have to happen. I'm very uneasy in having data that's even somewhat sensitive not encrypted. We'll probably need to look at multi-factor authentication the higher we go up in terms of sensitivity, also with all the stuff that we're seeing going on with security in general. It's probably a good idea to do. One thing that I haven't seen mentioned here, but that we are very excited about, you saw that a lot of what we actually do is verifying identities, checking plans for use for data, those sorts of things. ICPSR has this project of a researcher passport where people actually develop a profile of, have they gotten trained for using sensitive data? Have they used sensitive data before? Do we know who they are? Those sorts of things. And we're very bullish on this. We think kind of the idea that repositories learn about who are responsible users of sensitive data. So in the UK data terms, we get a better shared sense of who are safe people. I think it's very promising for how we view sensitive data. And so we're very excited that ICPSR is doing that work. They're looking for pilot repositories to work with as they kind of work on the sharing stuff on that. So do get in touch with them if you have restricted data and are interested in working with that. And then some of the enhanced security technologies, such as trusted remote storage agents that are being discussed elsewhere here, to the extent that we have strong use cases. As you'll have guessed from the earlier parts of my presentation, a lot of our data don't actually have that strong use case for something as robust, but also requiring significant efforts as the TRSAs. And for something completely different, Julian asked me to briefly talk about this, and this was the best session we could find for it. And completely different type of sensitivity is anonymous peer review. So you have data that are probably not sensitive per se, but they're being submitted as supplementary data to a journal article that's under review, and the journal wants double-blind review. Now, Dataverse already has the private preview URL that's very useful, but of course that doesn't anonymize the data. And so you actually have to do two things if you want to provide anonymous access to data with that private preview URL. One of them is relatively easy. You go into the metadata, and this is actually an example of a data set where we did this before we had this feature. And everywhere where the authors are named or other identifying information are named, you write something else, like we did anonymized here, here. That's annoying and it's a bunch of work, but worse still, the depositors will always show up in the version table. I think someone from TDL actually pointed this out when this was discussed on GitHub. And the only way to get rid of them there is by modifying the database, which just generally isn't a great thing to do, and also requires, someone with access to the database to be involved in that process every time. So it's time consuming and kind of all around not great. What we built, and by we, I mean, we told Jim what to build and Jim built it, is a 2-click version of anonymous peer review. It works through the interface of creating a private URL that you're already familiar with, but as you get ready to create that private URL, you get a second option for anonymized access. And so you click that, and then you get the private URL. Actually have private URL for this data set here for you to take a look at if you're interested. Jim already put the PR into the chat. But what you can see here is it says authors' names withheld in every relevant field, including the version table. What's nice about this is just a view. So in the actual data set, if I log in as the depositor, as the curator, I still have the full information. I don't have to go change this back and forth. And I think that's at the installation level, the fields that are anonymized are configurable. So we currently have creator, contact, depositor, grant information, and related publication information withheld, but you could specify further fields that would have to be withheld. And that's it from us, and we hope that makes it into Dataverse soon. We are, I think we already have the first user of this, and we're getting increasing requests for peer review accessibility during review. All right.
That was great. Thanks a lot, Sebastian. I think the QDR use cases are really pushing us along and expanding the sensitive data and options for the UI. So thank you. Next up, we have Julie Goldman, preparing sensitive data use throughout the data lifecycle.
Awesome, thanks, Tanya. Yeah, hi everyone. I'm going to be taking kind of a higher level look at things, but I hope this is a helpful presentation for this session. I just want to thank Sonia and Julian for inviting me to participate in this session for the Dataverse community meeting. So as mentioned, I'm a data librarian. I'm embedded at Countway Library. At Countway, we serve Harvard Medical School, the School of Dental Medicine, School of Public Health, and 16 affiliate teaching hospitals. So when I talk about sensitive data, I typically mean clinical data, confidential personal information that must be kept secure and accessed only by, authorized users. I know there was a question about, how do we define sensitive data? I don't have time for my full definition slide that I usually show in my presentations, but I'll drop the link in the chat for you to take a look at those. So with my work, I work with researchers, students, and other stakeholders to understand data management practices throughout the research lifecycle. So that's the focus of my short talk today, to talk about preparing for sensitive data throughout this data lifecycle. Of course, one should prepare for data work before beginning any project. But as we know, there are these special and unique challenges and considerations with sensitive data. So jumping right in, I do want to have my slide about data management. Data management encompasses all activities related to storage, organization, documentation, accessibility, and dissemination of data. Effective data management is also crucial to establishing the governed or appropriate accessibility of data after a project's conclusion. I like to say proper data management is characterized by standardization, where every member of a research team is following, the same set of practices and procedures. And when I talk about data management, I refer to the life cycle of data, You've probably seen this version of the life cycle. There are many out there. Just Google and you get overwhelmed. But here is our depiction at Harvard of the research data lifecycle, showing how data management happens, throughout the project. Our particular model includes stages for research planning, the active research work, and dissemination of research. So the first takeaway here is that you have to plan for the entire lifecycle of data. And the next takeaway is that RDM is a continuum of practices. It's not a one and done activity. So we've created this expanded view, not to overwhelm you, but so that you can see in those larger stages, there are many activities, resources, and entities that may be involved, depending on the type of research project, the type of data, and where the research is occurring. So we're going to quickly walk through these stages and some key practices for working with sensitive data. So first, obviously, before data collection, you must plan for how you will work with the data you collect. This includes preparing for anonymization schemes, keeping participant information secure, documenting identifiers, and getting participant consent. So the important takeaway here is that you do not get consent from your research participants, you cannot share that data you collect from them. This does point back to Sebastian's point about coordinating with the IRB, your proposal and all the requirements. So if you know you will share data, get permission for participants up front. If you don't know if you'll share data in the future, consider getting permission anyway. So next, during data collection, you should be collecting only identifiers necessary using password encryption, protection, and codes. For data analysis, removing direct identifiers not needed. So sensitive data that contain potentially identifying information will likely need to be modified prior to sharing, as we know. There are a few types of anonymization. We heard about adding noise from Raman. I'm not going to go into these strategies. That's not the point of this presentation, but the level of de-identification depends on what your sharing plans are. It's also a good practice to evaluate and curate data prior to sharing. So there will be situations where sensitive data is needed or are needed or included in the analysis. And Sebastian again talked about, challenges with sharing qualitative data. So trying to remove as much as possible in order to share publicly. Again, your options for accessing and sharing data will be based on the method of de-identification applied. So statistically, de-identified data sets are generally approved for public release and deposit to open access data repositories, but that's obviously very time consuming and expensive. Mediated access typically indicates a metadata is public, but access to the data is via a custodian. And then, of course, restricted sharing means sharing data only with approved collaborators or other investigators, typically through a data use agreement or other contract. So since we know repositories have different requirements and abilities to handle sensitive data, ideally you need to plan for which repository you will use for sharing and what you need to do to prepare your data. The final takeaway from our life cycle is that data storage concepts must be included at all stages. The type of data you are working with or the data security level will dictate where and how that data needs to be stored or handled throughout the process. Most institutions indicate security levels for research data. Harvard maintains a multi-level security system, so 5 data security levels, indicating what tools and platforms can be used for each level. Overall, data storage is about understanding where the data should be kept to protect the integrity of your data and the data subjects. All right, so when it comes to sensitive data, especially, you need to plan for the entire data lifecycle. Planning for or planning your research process can prevent those kind of unpleasant surprises down the road and really save you time, money, effort, all those arguments for creating a data management plan. And data management plans have become, the standard or most utilized form of research planning, mostly because funders have started requiring them. Here's my quick historical timeline of requirements from funding agencies. I just want to point out that most recently, NIH came out with a new policy calling for more robust data management and sharing plans for all their research grants. This goes into effect in 2023. And at Harvard, we have already started addressing this policy, which I'll share in a few slides. If you're not familiar, what is a data management plan? A DMP is a written document outlining procedures for all that data collection, all aspects of organization and processing before data leaves your lab or your institution, and then having a plan to have that data leave your lab so that others can find it and access it in perpetuity with that proper attention to any legal or ethical concerns. So it should include those practices we discussed, like participant consent, de-identification strategies, sharing plans, storage needs. However, I like to say that a DMP created is just, the beginning. It's important to create a plan, but it's equally important to keep your plan up to date and communicate it with everyone involved in managing and sharing that data. So for help creating a DMP, there is the DMP Tool, which is an online resource that includes the many agency and organization DMP templates. DMP Tool is an open source project, and anyone can sign in to access these templates and create a DMP. I believe there's also DMP online for those not in the States. Many institutions like Harvard are institutional members of DMP Tool. This allows for, authentication sign-on, and many institutions provide tailored information assisting researchers. We have just completed such a project at Harvard. We created 2 Harvard-specific templates that keep the structure of a typical DMP, but they also include example texts, guiding prompts, pointing to Harvard policies and links to resources. So our 2 new templates available to Harvard researchers, one focused on biomedical data, the other for general research. We're encouraging, the use of these templates to help researchers get familiar with DMPs ahead of the policy mandate. And our campus is very distributed, so it's a single point of access for researchers to find this information. And in my last remaining seconds, I do want to provide an example text that is available for researchers to review and understand how they should ideally be answering the sections and questions in a DMP. So for example, here's a blurb we provide that hopefully illustrates how one, if they are working on human subjects data, can balance the act of sharing while keeping participant data confidential and allowing for reuse of data. What I like about this answer is it addresses those key elements that I mentioned. So receiving participant consent, a plan for data dissemination, ensuring only de-identified data will be shared, and indicating data can only be reused through a data use agreement. We've communicated these templates across campus and also highlighting the importance of planning through our tutorial video. And then final takeaway, one should prepare for working with sensitive data before beginning any research project to combat, the challenges that we'll be talking about in this entire session. Thanks everyone for listening.
Thanks a lot, Julie. It's really helpful to get the overview, but then also see how things are going specifically at Harvard. Next up, we have Carolyn Wood, also from Harvard, with health policy research data.
Hi, everyone. Thank you, Tanya. So I work at the Department of Healthcare Policy at Harvard Medical School. And I'm going to kind of give an overview of our operation. And you'll see as I go that our department has been restricted in how much we can participate in data repositories. And there's a lot of red tape that I'll go through now that presents challenges as we kind of evolve and move forward. Okay, so here at the Department of Healthcare Policy, we have an interdisciplinary faculty, which means that we have practicing physicians who are conduct research. We have economists, we have sociologists, we have statisticians. We also have people with dual degrees in multiple of these fields. So it's highly interdisciplinary and highly collaborative. Some of the topics we look at are financing and delivery of healthcare, access to healthcare and health disparities, clinical effectiveness, statistical models, quality of care and patient outcomes, aging and disability, and technology assessments. So our data sources, we primarily have secondary data at healthcare policy. We do generate some of our own data, mostly in the form of surveys, but the majority of our data is acquired from other organizations. So that includes administrative billing claims at the national, state, and private payer levels, international, national, and regional survey data, clinical data at the procedure level in clinical registries, and linked billing and electronic health record data. So obviously we're talking about human subjects research here, and with health information, a lot of privacy and confidentiality concerns. In addition to these data sources, we will also use financial data, geographic data, drug and device information, employment data. Some of this may be publicly available. Some of this might be acquired through a data use agreement. And we also access data housed at other organizations through contractual agreements. So currently the department has around 180 active data use agreements, and this is a lot for us to manage. And this is partly why. So with health information, there's a lot of regulations, and also with federal information, a lot of security standards. So with health information, we're sometimes see HIPAA, even though we are not a HIPAA covered entity. We find that when we acquire data from HIPAA covered entities, a lot of those requirements will flow down into data use agreements. Every state has its own version of privacy protections for health information. And also when acquiring federal data, there are standards that sometimes we have to tangle with, which include some of the NIST frameworks and also relatedly FSMA, which I won't get into, and I hope none of you ever have to as well. And additionally about FSMA, and some of that is it's very resource intensive, and it's the kind of security framework that as a department is very difficult for us to find the resources to sustain. So when we're talking about secondary data under data use agreements, just a few things to remember about that. This is a legally binding contract between institutions. This can mean where someone's affiliation is can impact whether or not they can access data. That's a challenge for collaboration. We have to protect individuals' privacy, and we are always required to keep things confidential. This can be either because of its individual information or because the information is proprietary. So with a corporation, they might just want, kind of similar to a non-disclosure agreement, they don't want the information shared. Prohibiting the transferring of data, this can also make collaboration difficult. Requiring the data be used for research purposes only. Happily, we never have a problem with this. And define authorized use and users. One challenge we sometimes have with data use agreements is it's a very narrow defined scope of work. And other times there are specific requirements and procedures for any individual who's going to access the data. Sometimes they stipulate penalties for violations. This is, can keep us up at night. So beyond reputational damage, sometimes there are financial concerns, or perhaps we would lose the ability to access a very important data set if something goes wrong. And also they may incorporate those regulatory requirements and security standards I referred to from all these different levels. Also worth noting, sometimes we do have data from other countries. So we do sometimes deal with GDPR and then looking forward to other countries as they kind of get on board to similar kinds of requirements. And then also another challenge is the definition that might be in place for the time span that we can use the data, requiring destruction or return at the end of the set term. Oftentimes it's difficult to define a project's lifespan. With grant funded projects, for example, oftentimes there are publications still in the works. And having to destroy data while things are still winding down is a big challenge for us. So my area of expertise is data security and compliance. So I'm going to kind of touch on that, the tangled web that we weave. So the use of sensitive data is documented in many systems of record at Harvard. We have the IRB system. We have a system for data use agreements that is used with the workflow with our grants and contracts team, which also connects to our funding. We have a system for that. And it's worth noting the funding because funders often have, they require data management plans, and they may also have specific requirements for data management. And then there's also IT groups and security groups, which can be separate groups. Sometimes you have the IT resource, which is separate from the security team. And so call back to the data lifecycle that Julie brought up. You really want to stress yet again, data management plans. Plan at the start so you don't have surprises later. This can happen quite a bit just from knowing where you can store certain types of sensitive data. There are very specific resources that people can use and very specific resources people cannot use. A password protected laptop will not always be the right choice. And if a researcher is going to have to purchase anything for their project, they need to make sure they have the funds to do it. That's just one example. Another example is destruction. Sometimes destruction can be very difficult depending on the resource where data is stored. I have heard stories of having to wipe people's laptops entirely in order to comply with destruction terms. So that's another thing to think about at the start, not when you get there. So what we've done here at Healthcare Policy is basically become our own silo. We have specialized and dedicated resources to ensure that we can comply with all of these requirements. We have our own IT staff. We have our own IT infrastructure. Our IT staff is familiar with the baseline standards and the processes and procedures that all contribute to complying with sensitive data requirements. And then there's the compliance office, which I run. And so we kind of are the connector between all these various groups that are involved with using sensitive data. So we provide support in administrative processes. That can be the IRB, it can be acquiring a DUA, it can be writing a data management plan. We work with our IT group to advise on security controls. So we might read a data use agreement and tell them what a specific directory needs in terms of security. We authorize data access. So whenever a new user wants to access data, the compliance group will review the IRB protocol. We will review the data use agreement, and we will review the security plan to make sure that it incorporates this new addition. And oftentimes there are processes with data providers where you have to provide documentation in order to even add someone. We also have centralized our training and outreach specific to our research environment. We found that our corner of the medical school is pretty specific, and so we've developed our own training, and we have our own outreach to address the specific nature of that. And then we also have, now we have a data manager who manages our largest data collection. And he's specialized in this specific kind of data. He's a great resource. And he also works closely with researchers, IT, and compliance to make sure that everyone is on the same page and doing things as they should. And we also have a layer where he reviews uploads and downloads from our server to ensure that people are not downloading sensitive data inadvertently. So we've also streamlined security as a department. We've had university IT certify us. If you recall from Julie's slides, Harvard has 5 security levels. We are certified at the 4th out of 5, so second highest. This means all data in our department is treated at that level. And it means we don't have to customize a system every time we acquire a new data set. So we have baseline standards, and we know that everyone is on board with the same idea of compliance. And this also allows for us to centralize and streamline security documentation and data management plans. We don't have to reinvent the wheel every time a new project starts, every time we acquire a new data set. And then also the DUAs that we have, a lot of them require security controls beyond what the university policy will require. And so that's another additional standard. And we've actually built a second system to accommodate our federal claims data, which we depend on quite a bit as a department. And we've built this with enhanced logging and monitoring and encryption at rest in order to ensure that we're kind of one step ahead on what we should be doing with that kind of data. And then findability and efficiency has been a great challenge for us. Years ago, PIs were acquiring the same data sets without knowing it, which means they were paying for the same data sets. And so in order to kind of find efficiencies there, we built a database that could capture a lot of the metadata surrounding these data sets. So maybe we could find efficiencies that way. And so the central compliance and data management rules have done a lot to allow for reuse of data instead of applying new every time. And another goal is to reduce the administrative burden for researchers. As I hope I've illustrated here, the administrative burden of this kind of data is significant. And researchers simply don't have the time to address all of these compliance concerns themselves. And then I kind of wanted to address repositories and why we still struggle to participate in a lot of sharing of data, while the NIH has and other funders have been pushing more sharing of data. So data acquired under DUAs cannot be shared. So that's the bulk of our data. And so sometimes we have to find other ways of kind of participating in the effort of sharing. So we might share code, we might share methods. And we might point people to where we acquired data, even if we can't share that data ourselves. And then sharing, we do have some primary data, primarily survey data. And kind of as we've covered already, that requires an understanding of the identification standards, which may vary. When you compare HIPAA to GDPR, the terminology is entirely different. So it requires a certain level of expertise. And then we do leverage data from repositories, but oftentimes this means acquiring de-identified data sets, which we'll find often in clinical research repositories. So also another focus of our faculty is finding advanced computing methods to use this data. And also another challenge is knowing where to find useful data. And so we have a disparate group of experts, and so they're often collaborating and sharing and pointing people to new places that might prove fruitful. All right, well, that's it for me.
Thanks a lot, Caroline. It's really great to hear about the resources and the specific examples, processes, methods that are put in place. Thank you. So the last presentation we have before Q&A is implementing privacy technology and Dataverse software from Akash Sharma, Havard Johansson, and Thomas Nilsson.
Yeah, just give me a second.
Of course.
So a small update, we changed the title of the presentation to make it more relevant. So I'm Akash, and I work with Thomas, Dag, and Howard, who are my colleagues at UIT, the Arctic University of Norway. And I would like to thank Philip for providing this opportunity to share with the Dataverse team and also so many users of Dataverse. It's probably not new for you, but Dataverse is quite a popular tool. And if you see on the metrics website, you have millions of downloads and lots of data sets regarding social sciences or medicine health data. And there's this problem with sensitive data that everyone feels like they should not be public because they have trust issues that have been shared earlier by presenters, and especially de-identification attacks in cases where individuals in those data can be identified. And there was a really nice example by Raman and also by Sebastian about the village. And this becomes more relevant, especially in northern Norway, where village sizes are less than 200. So it's really easy. It can become really easy to de-identify those individuals. And especially being in Europe, you have new laws such as GDPR, which allow those individuals, even though they have consented earlier to have their data shared, they can revoke it. And those have to be implemented by the researchers. We looked at some of the data at the local ethics committee. We don't have IRBs in Norway, but we have a centralized ethics committee and has 4 different parts in Norway. And we looked at, there are lots of changes that are being approved by them. And when we asked them, they said, like, whenever a new researcher is added to a project, that has to be approved by the ethics committee. Whenever there are new threats on the data that they have identified, they work with data production agencies. So that has to be approved, especially in terms of disclosure. And also when new laws are implemented, that has to be passed through IRBs or ethics committees down to the universities. So these keeps on changing. And also the opinion of people. In our study, we found that opinions are not consistent with the existing studies. People, their belief about privacy, how much they care about their own data, it changes a lot. And not just what it is, but also who is being shared with. So in case some individuals might be okay to share data with other Norwegian researchers, but they might have a problem sharing the same data with other researchers. So, and that has to be taken into consideration. We looked previously in Julie's presentation that a data management plan has to be provided along with the proposal. And then it goes to approval and then the data collection and analysis. And at the end, with dissemination, you share that data, provided you have the consent. But a lot can change between a project's life cycle. So between proposal and dissemination, all those threats and the changes in the laws that I mentioned earlier can happen. And the data management plan has to be updated, same as the sharing. So in reality, it can go like this. So when it's non-trivial, we probably need a system that can support these dynamic security policies that arise from the whole dynamic nature of data collection and privacy in general. Also mentioned by Caroline was the identification experts. So based on the simple example would be leakage of census data. And if it's leaked, there might be more risks to certain data that has been shared openly. And we see that there's this tension between going open research, so where you try to make as much as data public, and then the privacy risk. And when you have risk and you don't know how to handle them, projects often end up in silos, and where you have to keep them in a secure facility and only allow few people. And that goes, there's this, so we thought of trying to solve this crisis by, as Caroline mentioned, by keeping a data sharing compliant. And what I mean by compliant is not just with the laws, but also with the wishes of those individuals that are in the data itself, maybe not directly by their personal identifiable information, but if there's any risk to their data and they can be identified, they are the stakeholders in that data. So we built LOPI, which means permission in this here Northern Sami language, which provides a distributed metadata layer over the data itself, which can be stored in multiple repositories, as we know that there are more than 80 instances of Dataverse. And the key feature of what we provide is that the policies, the data access policies or security policies can be updated in near real time, so that you don't have a stale policy which was approved 6 months ago, but you reflect those policies as quickly as possible. So here we also build this without wanting to have users create a new account. So we were able to integrate it with existing authentication services, as pointed out by Sebastian, that you want to identify users by their affiliations. And even though it's distributed, it provides a centralized list of all the data sets that are available in different repositories. And you can access data. Like in this example, you might not be authorized, but when you submit an application and it's approved by IRB or ethics committee regarding a risk and your affiliation and the laws, you might be able to check that data out. And you can also check whether your portion of data is compliant with the current state of data security policies. And it might happen that while you had the data on your laptop or your working machine, the policies have changed. So we disseminate that as well to all the users as well as the repositories, so that in case this can be checked periodically, and if you're not compliant, you could be notified. There are a series of actions that could be taken, but that's beyond this talk. Let's look a bit into the structure, the architecture of LOPI. So we built this while keeping the stakeholders more or less in control. So ethics committees or IRBs, and the subjects itself, because they can revoke their consent. And Policy Store keeps the track of all the policies and their applicable date in terms of auditing. And these audits or compliance checks can be requested by IRBs or the subject itself. And whenever a researcher is trying to access the data to do analysis, they have to go through compliance engine. Another key feature of LOPI is that we don't want you to store data in a certain format or system, but you can use your infrastructure at the university or institutes, and also you can use that in a cloud-based service if you want to. So here we look at how the updates are disseminated throughout the system. So imagine these blue as different instances of Dataverse. So we use gossips instead of direct messaging in that sense, because it removes the bottleneck to add the policy store, so that all the instances can share this information among each other. And also it provides good scalability. As a computer scientist, I can talk about that. So we built a system, and in a gossip, we contain information about the policies that are there, what versions they're maintaining, and yeah, the whole policy itself. We are not done yet, and we are not public in that sense that we can let other people use, but we are working on a low-code policy language so that IRBs and ethics committees can write their specific policies, so that not just, so when you have a data management plan, we could translate it directly into a data security policies. We are working on compliance, formal proof for these compliance, so that we can go to ethics committees and use them. We have built enforcement tools using Fuse, but we are also working with other technologies such as Intel SGX. For some type of data, for example, medical data, in case of hospitals, there are laws that prevent them to be shared outside a country's boundaries. So on those cases, we are trying to work to build a cloud-based service so that even the medical data from individuals in Norway can be shared with researchers, while the data never leaves the regional boundaries of Norway. We have some collaborators in sports teams here, and also with fisheries crime, that they both have different requirements for how to handle sensitive data, and we are working with them. In conclusion, LOPI provides a distributed infrastructure which runs on top of Dataverse to provide compliant access all the time. It's scalable across different institutions and different ethics committees. So you don't have just one committee controlling everything, but multiple can do it. And we provide the facility so that the Dataverse installation can be cloud-based or even running on a local infrastructure at a university or institution. These are some of the references, even some of the papers that we published. And yeah, that's the team. If you are interested in this, or if you want more answers regarding, if you have any questions, you can ask or email us anytime. I think the slides will be available later as well. Thank you for your attention.
Thank you so much.
Yeah, thank you, Akash, and everybody else. So I'll turn it to Tanya for Q&A.
Thank you very much. And thank you, Philip, for taking notes on that session, because I think it was going to be easier for you to talk about it than me on Twitter. So I really appreciate that. We are going to head into Q&A, and let me just, I just want to see how much time. We have 15 minutes for questions and answers. And what I'm going to do is share my screen, because I have some of those questions available here. So we received some questions ahead of time for this session. And if I can find it on this beautiful document. Julian, are you in the document as well? Maybe you, because with all the note taking, I've just kind of lost where we are with all the questions we put in here.
Yes. There's a section on page 6 now called questions and answers here highlighted. But Tanya's been adding additional. You're welcome. Tanya's been adding additional questions to that list. So it's not just what we're.
Right. So this is open to the panelists for their replies. So we have how can sensitive data be made available in Dataverse? What features are available in order to implement usage consent or embargo periods, and what tools can be used to anonymize data? So I think we've actually talked about some of that content here today. We have an embargo feature that's being developed. Right now, you can put an embargo manually, but there's nothing to remind you to go in and, end that embargo or update that embargo. So as curation managers of the repository, when we see something is going to expire, we do due diligence and contact the PI and see if they want to extend that embargo for any reason, because they may have forgotten about it. That's what you do as repository managers to make sure their data are protected. But I know there's a tool being worked on, and I don't know if anybody's in the group that could possibly put that GitHub ticket in here into the answers as well for this. And then, of course, we talked about OpenDP and DP Creator to solve some of the sensitive data sharing issues. So next we have a question: do any Dataverse community members keep sensitive data in separate storage vaults? And I can't remember if it was this session or the last session on licensing, etc. I think that we talked about keeping, actually Sebastian mentioned keeping some of their sensitive data in a separate storage area. And I also, running the Murray Research Archive Dataverse, the non-de-identified content is not on Dataverse. We de-identify the content that actually goes on Dataverse. We also keep files that have different identifiers in them but have been de-identified. So we have like consortium use level files that are restricted to consortium members, and then we have public use files that are restricted but they don't have that identifier in them. And we make those available to different groups of users who also go through an application process. That's in the Murray Research Archive in terms of keeping things in storage vaults. Our video data and our audio data do not go on the Dataverse. We digitize those and we either make them available. Some of the restrictions are that they can only be accessed on site. And then for the ones who can get a copy, we can send them off, but we're very careful about how we do that and getting the copies back as well and making sure they sign additional data use agreements. And it can only go to, certain people can view video data, and audio data requires permission from the director of the archives, because we don't de-identify audio data. We'll de-identify the transcript that we put up, but the actual audio tapes don't get de-identified. So if somebody else wants to talk about how you're keeping sensitive data in a separate storage vault.
We experimented with keeping some of the sensitive data in Azure blob storage and then facilitating the sharing of that using LOP. But that's still a tool in work because we want to make sure that everything works fine before actually releasing it to the public. But yeah, we actually worked on creating a connector for cloud-based services that provide encrypted storage.
Mm-hmm. Yeah, and one of the things that you just mentioned something, it's going to come back to me. I have so many thoughts in my head about this because I've been working with this collection for so long. It will come back to me. Okay, and then guidelines that you create for researchers and reviewers. So anybody want to talk about, I mean, we have data use agreements based on each data set, at least for my qualitative sensitive collection. We have data use agreements that are based on each data set. Most of that template is consistent, but then depending on the type of data, there might be some additional addendums that we add to each of those agreements that we have for the data that we share, which are considered highly sensitive data. And then researchers who access the data, sometimes not only are they agreeing to an application form that has all of our terms that have been approved by the Office of General Counsel at Harvard, sometimes there's a printed form that goes along with their application from the agreement with the PI that they have to sign in addition to the application and send in about how they're going to store the data once they access it, and that they'll be returning the data, that nobody else will be having access to the data, and that the data will be used on a standalone computer so that other people can't have, access it. So we have a number of conditions that we would love to be able to solve by having things on Dataverse, but that's just not possible yet. And data tags, we've talked about data tags, and what I wanted to, this is the point I was going to make, is data tags is going to support up to level 3, which means our audio and video data are never going to be put up. Which is, fine, but there's a limit there to accessibility. And at some point we have to figure out what's going to happen with that content if we're moving towards not having a lot of physical space for people to come in and use data. Anybody else want to lend to that? On guidelines for researchers and reviewers, because I'm thinking, Caroline, you might have something, Julie.
Yeah, we provide a lot of guidelines. Some are data specific, and some are kind of just more like I was talking about how we operate at a standard security level of the department. So we have all kinds of guidelines, from data management to just kind of user behavior to referencing data in publications is another tricky area. We had a big data set where we couldn't refer to the data provider by name. And so, we really have to provide a lot of guidelines depending on what data people are using.
And I was talking about earlier in the licensing in terms of use section about how I have a small data set of about 20 subjects where most of them have a common license, but a few of them you can't publish on. And that I have to be very specific in the Dataverse tool and put that information right in the file description because somebody's likely to miss it. And I want to make sure that it's for our own obligations, that it's clearly mentioned that they can't do that. It's easy for me to duplicate the information that's in the file metadata level when I'm looking at it to a user rather than going to search for it every single time when you're reviewing 360 data sets for every application that comes in. But we, talking about that kind of guidance on sensitive data. It's like you can use it, but you can't publish on this. You can't publish directly from the transcripts. You can't use quotes. You have to, hide everything and make sure you're using it as per the agreement. And
We
I
also
find it.
have,
Oh,
oh, sorry.
No, go ahead.
We also have cell suppression guidelines from data providers. So with tables and charts, we have to be very careful about the figures we're including, and that relates to privacy and confidentiality. But that's kind of like a nice, easy rule that can be applied broadly. So cell suppression is a really good one for us. And we also have one data set where you can report on all states but South Carolina. And so, it can be a little very specific. So kind of identifying where we can have these broad rules, like cell suppression, is really important.
Right. Okay. iRods. So I see it's being filled out by Dawn right now. Are members of the Dataverse community thinking about using iRods? So Odom is using iRods as part of their preservation strategy, and Bit Curator bulk extractor plugin. You want to tell us a little bit about that, Dawn?
Hello.
Hi.
Well, that whoever corrected my formatting there, thank you. But that's about what I was going to say, that we started using iRods 4 or 5 years ago, and I'm experimenting with its S3 plugin now, since Odom is getting ready to move into Amazon soon, we hope. But as we upgrade, we're going to be able to have multiple data stores. And it's been a couple years since we've done the experimentation with the bulk extractor, but we wrote an iRods rule for that to scan for and write manifests of sensitive data that it found. Thankfully, the only thing the one file that it found we already knew about.
Okay. I know that's something we want to do in the Harvard Dataverse repository, is go back and look at files that may have identifiable information, because as a small team of curators, we review the content that come in every day. And we reach out to researchers, and we try to keep track, obviously, of every communication that we have with researchers that may have sensitive data. And a number of them just never reply back. And it's a constant battle to, contact them and make changes to their settings for their data sets so that files are restricted. Because if you do that, you're changing the version of the data set. So we have to be very careful with that. But I know that's a big project that we have in mind, is how to go back and check for sensitive data. Because now that more and more people are sharing sensitive data, you'd be surprised at what I find deposited. And that's from our Harvard people as well, who say, oh, I needed to share it. Yes, but you weren't supposed to share it like that. So, and then the thing is that, some of those data sets are shared, and since it's self-curated, they publish it and they're downloaded. And then because they shared it openly, there's no way to track who downloaded the data. And so there's this education level that we try to provide to users if they actually contact us first, which is to tell them that even if you de-identify data before you put it up, there are tools that you can use to track your users, so that if you find identifiable content, you can reach out to your users and say, hey, we need you to stop using that. And here's the clean version, get rid of the copies that you had before. But if they don't contact us, they just they don't know, and they don't do the extra research needed to do that. Okay, so I have added some links to the iRods and the Bit Curator.
I wonder if I may, Wim put the comment from about the dance tool, which I think sounds interesting, to identify sensitive identification risk and legacy data. One other thing on which I know there is an open ticket on Dataverse is pre-flight identification of obvious direct identifier, which is particularly important, I think, for self-deposits data, right? So one thing that we see a lot is that just people dump their Qualtrics output, including IP addresses, into Dataverse. And that would be trivially easy to, like, IP addresses are pretty easy to regex. So something like that would be quite easy, since we're extracting variables anyway, to flag and say, oh, do you really mean to share this?
Right. And you know, one of the things you pay attention whether you have a Dataverse installation is the guest book, because the guest book collects IP addresses in the back end, right? So we don't use it to contact users on behalf of depositors. We let them know that we don't use the IP addresses. But one of the things that we always do with people who are using their guest book to write reports is make sure they know that they need to de-identify their guest book and remove content that they shouldn't be sharing. You know, they might want to know, oh, who are you? If they don't have a name, but they're still getting IP address, and they might ask for a first name or an email address. You need to de-identify that before you actually use that document that you generate from the Dataverse repository, from the Dataverse software, before you make it available. Okay. So I think we've talked about what else is in the development for sensitive data. For now, I think that's all we have, unless we didn't talk about something. We didn't invite somebody to present something in this session. And is anyone using the Dataverse software for sensitive data now? That I know of, no. And I know that the Harvard repository right now is the only one with plans to integrate data tags. I don't know about other, Sebastian, you guys gonna be using data tags like QDR?
Probably.
Okay.
We don't, I mean, right, parts of them, like the labeling system, yes. The automated interviews, probably not, because we have curation interviews for everything.
Right. So yeah, and I know that that's, you know, that's moving ahead. It's just taking a lot longer than we expect, but you know. And then Rory, how are you, Rory? How is GDPR, more specifically the increasing expansive and has restrictive interpretation and extensions of GDPR, impacting the deployment and configuration of Dataverse repositories in the EU? Anybody here that can talk about that?
I think about, this is Julian, I think about the work that's been done to either, like, there's definitely been discussions to remove user account information from repositories, or at least to restrict access, because I know that GDPR kind of requires such a mandate for that.
Okay.
Yeah,
Maybe,
so
oh, sorry.
One thing that I find is that there are more myths about GDPR than realities, right? So especially with good consent, the research data sharing part of the Dataverse installation is really fairly unproblematic. The only tricky part is the revocability of consent that's in GDPR, right? As long as you have good consent for data sharing, research data is very clearly shareable under GDPR. Right. You have the messiness with, you know, anonymization, pseudonymization, etc., but that doesn't really affect you as long as, you know, you've clear consent. So you need to pay more attention to that. Some of the stuff on the software side, you know, what do we store in Dataverse? Google Analytics is super problematic, which most of us, I think, use for just basic analytics. So that's something that we might need to revisit. So on the software side, there's a couple of things, but the research data side, I think it's sometimes getting overblown.
Yeah, I agree. That's why my question was about deployment rather than data sharing. Akash, if you're still here, you made kind of a quick but interesting reference to cases where I think it was medical health data was not allowed to be shared or outside of Norway, and how you're working on a tool to make it possible for people to access the data while the data itself still was situated in Norway. Could you talk a little bit more about that?
Yeah, so let's say you have medical data of about 100 patients. So it is legally possible to get the data out of Norway, but then you have to go to each individual and get their explicit consent. But the other side is that if it's de-identified, even though there's you can claim that there's no personal information in that, you can't take it outside Norway. That's restricted. So especially in the research where people are using these Fitbit devices or any other smart device, health devices that has a cloud service and outside Norway, the researchers are explicitly required to get the consent from individuals. So that's one of the issues. So what we are trying to build over the summer or maybe in the next 6 months is that so that users can or researchers can check out the data on a cloud service inside Norway. We have few data centers coming up. So you are still complying with the law while you are running your analysis. Otherwise, the data sharing might happen over USB pen drives, which is kind of unethical, but it still happens.
Great. That sounds absolutely fantastic. Is that something that's specifically tailored to Dataverse, or is it a more general, does it have more general applicability, the tool you're developing?
It would be general, but since talking to Philip, we have been adding connectors to Dataverse.
Dataverse,
So
okay.
yeah,
Fantastic.
So, yeah, thank you.
Okay, so I will move on to, what time are we supposed to end? I think we've gone over our time. So I'm going to leave it at that just because it's been a very, very long day. And I wanted to say thank you to our panelists. I really appreciate you guys being here. Sebastian, please go run and take care of the one who's going to deliver. She needs you more than we do right now. And I want to thank all of the groups that participated today and the individuals. I can't wait till next year so that we can build on what we've been talking about now. So I appreciate it all. Everyone stay safe, and I hope to see you guys for the rest of the meeting, except Sebastian. He's going on vacation, so he might not want to work. But we really, really, really enjoyed this, and the conversation will continue. So thank you, and farewell.